Hello, proximity math here. I'm going to go over the 2020 Aime I number 8. A bug walks all day and sleeps all night. On its first day, it starts at point O, faces east, and walks a distance of 5 units due east. Okay. So we can represent O here, and then it goes 5 units east. Okay. Anyway, 5 units here, and then each day, well, it rotates 60 degrees counterclockwise each night, and then each day it walks in this new direction half as far as it walked the previous day. So we rotate 60 degrees and walk 5 halves, half as far, then another 60 degrees and walk 5 fourths. And then the bug gets arbitrarily close to a point P. Then OP squared is, well, we have to find OP squared. Okay, so basically it approaches a point P, and then we have to find the distance squared. So first of all, we have rotations and a common ratio. So you can use complex numbers for this. De Moivre's formula says that R cis theta raised to n equals R to the n cis n theta. And any complex number can be represented as with a radius and an argument theta. So for example, if we have some z, its absolute value is r, there's a distance from the origin, and then the angle from the positive x-axis is theta. And this can also, cis theta is also equal to e to the I theta. But anyway, this is the Moivre theorem, and we can use this here. So if we represent this as the complex plane, then represent point P as z is equal to 5 plus, we're just adding a bunch of complex numbers for going in these directions. So, and then the next complex number in polar form is, okay, 5 plus 5 halves, cis 60, which is cosine plus I sine of an angle. 60, because we're rotating 60, and then this has rotating another 60, so this is 120. So it's rotating at another 60 degrees. And we have 5 fourths, cis 120, and so on. We'll have 5/8 cis 180 and so on. Okay. And this is actually a geometric series. If you look at the de Moivre's formula, then the radius is 5, and we have cis 0. But look at the next term. Cis 60 is in this term, and then the next is cis of 260, which matches up with this. And also, this immediately tells you that 1/2 cis 60 raised to the n is going to be, well, if we square it, we get 1/4 cis 120 degrees, and then we get 1/8 cis 180 degrees, and so on. So it's just that, all those terms, but multiplied by 5. So 5 times 1 plus 1/2 cis 60 degrees plus 1/4 cis 120 degrees, which is also 1/2 cis 60 degrees squared. And then we have the next term is the distance is reduced by a factor of 2, and we're adding 60. So this is just the infinite geometric series. here, okay? And using the formula for it, we have 5 over 1 minus the ratio, which is cis 60 over 2. And OP squared is the absolute value of z squared, the distance. So that's just equal to the numerator's absolute value squared over the denominator's absolute value squared. So the denominator is 1 minus r, which is 1 minus 1/2 cis 60, and cis 60 is equal to 1/2 plus root 3 over 2. And this evaluates to be 3/4 minus root 3 over 4. And the absolute value of that is equal to root 3 over 2 if you evaluate it. Okay, so then the absolute value is root 3 of 1 minus 1/2 cis 60. And then this is just 3/4. And the top is 5 squared, which is 25. And then the final distance we have, the square of the distance is 100/3. And it asks for the sum of the numerator and denominator, which gives a final answer of 103. Thanks for watching.